Klebsiella pneumoniae is the capsule. It has usually a very nice, thick, robust capsule that's easy to find and see. And I've been growing this thing in a broth for a week, and it's just not doing much. You know, it's still clear. Now there are cells here, but you know they tend to clump together slightly. That's another character of a thick capsule, is the capsule is sticky. So when it grows, it tends to clump, and the clumps might be at the bottom of the test tube. Just a gentle resuspending, you might be able to fish around with your loop and capture a bit of it. I don't know if you'll be able to find them or not. Honestly, I haven't tried today, so it might be a challenge, but we'll give it a try. I'll show you how to do that first, and I'm going to start with two slides. One is going to be completely sacrificial, but it's important. Get this open. And I got to be careful when doing the capsule stain because I want the cells to be alive, basically. You know, I don't care that if they dry out, they die, but I don't want to heat fix them. Because if I heat fix them, they'll shrink, they'll shrivel up. And one of the important features of the negative stain, which is the capsule stain, is that you should be able to measure the true dimensions of the cell without the shriveling effect of a heat fixed smear. So be careful with the slide. You know, assume that those bacteria on your slide are still viable and could still cause big problems for you. Right? Gives you a hint there as to why it's important to us. It's a pneumonia-causing organism. There are lots of them. All right, so I'm going to put a small drop of my primary dye. It's Congo red. That's the negative stain. It's not going to stick to the cells. It's going to stick to the glass. But I'm going to just put a small amount of it on the close to the end of the slide. Just one drop is all it takes. Too much is not a good thing. And let me get my fire burning here. Alright, I'm going to add a drop of or a sample of my Klebsiella pneumoniae culture directly to that droplet. I'm just going to mix them up, mix that little inoculum on my loop with the droplet of Congo red. You know, just more or less homogenize it there. I'm going to take my other slide and hold it at an angle so that the droplet sort of makes contact with the edge of that slide, and I'm going to use that slide to smear the whole culture across. So in there is a very thin layer of cells that are surrounded by that negative stain, Congo red. Just get rid of it. Now, you got to wait for it to air dry. If you heat fix them, you've destroyed the purpose of the smear. That's why using too much Congo red is not a good thing. It's going to take forever for it to air dry if there's a big puddle of Congo red there. But, you know, if you do the smear properly and you don't use too much dye, it should only take a few minutes. And you can put it off to the side and do something else while it dries. Now, once it's air dried, you know, you look at it and you see that it's not liquid appearing. You counter stain with Manival solution. Manival solution is probably in your wooden box there, and it's the only reason we use Manivals. This is another basic stain. See, the Congo red isn't sticking to the cell, nor is it sticking to the capsule. We want to be able to see the cell. That's what the Manivals does. It has a different shade of red compared to the Congo red. So you're going to just gently flood the slide with the Manival stain. Remember, gently, because if you squirt it on there, everything's going to wash off. It's not heat fixed. 1 minute. And then a very gentle water rinse, because you know you'll wash them off if you lay on that bottle too hard. It doesn't have to be decolorized, but you know, try and get the majority of the loose color off the slide. I would let it air dry because the bibulous paper is most likely going to suck your sample right off the slide. Okay, so it takes a little bit of time and patience here. But when you see the cells you know, you're going to have black background because of the Congo red. You know, depending on the thickness of the Congo red layer, it could appear black, it could actually appear blue, it could appear sort of a reddish color. It depends really on how thick that layer is. But there's going to be a place in there that is empty because it didn't stain the object that's in there. Right? That's the encapsulated bacterial cell. All right. Now with the Manival solution, you'll be able to see the plasma membrane of the cell. All right, and that's the cell as reasonably close to its true dimensions in life as we can possibly make it. We didn't heat fix it. It is still alive. You should assume it's still pathogenic. But this clear halo is what you look for, and that would be a score positive for the presence of a capsule. It's glycocalyx. It's complex carbohydrate. The Congo red didn't stick to it. The the Manivals didn't stick to it, so we're deducing its presence by the absence of stain. If you see a cell that looks, or if you see something that looks like this, it's probably not a capsule. Right? What you see here is the cell lost volume in the process of drying out. Right, and it's sort of pulled away from the primary stain. It pulled away from the Congo red background, and it made that crescent shape. And it's probably not a true capsule. A true capsule you'll be able to see around the whole perimeter of the cell. Now that would, if you scored that positive, it might be a false positive. That's just an artifact. So be aware of how it looks. You know, if the halo around it is nice and complete and uniform, it's probably got a capsule. And a capsule is a virulence factor. And a cell that has a capsule has a natural evasive mechanism to get away from your white blood cells. So if it's able to avoid the macrophage, it's more likely to make you sick. And because Klebsiella pneumoniae often has a very thick capsule, it's very good at producing pneumonia symptoms. All right, simple enough, right? Mechanism pretty clear here. Okay.
So is a capsule stain a negative stain?
It is a form of negative stain because our primary stain stains the background, not staining the cell. That's the negative stain. This one gives you more information because we're using the counter stain that does stain the cell.
Oh, okay, I was trying to figure out why you don't use Nigrosa.
You could. If we were just looking at the negative stain, I would just use nigrosin. I would prepare the smear in the same way. I just wouldn't use a counter stain.
Oh, okay.
You know, you would just be finding open holes in that black background. But you know, that's probably not all that informative. I like to see a differential between the cell inside that halo and the actual halo itself. Okay, so I'm just going to put that off to the side there, and like I say, don't lean on it. You get it on your hands, go wash it off, because those cells are still alive. Now for the spore stain. Now there's only two important human pathogens that are sporulating cells. They're genus Bacillus and genus Clostridium. I'm not using Clostridium tonight. We'll use those some other night because they're strict anaerobes, and we'll use them in anaerobic metabolism. But for tonight, I'm giving you a specimen of Bacillus laterosporus. See, its name tells you what it does. That's your spore bug. Satisfies the genus designation there. It tells you about its shape too. It's going to be a rod-shaped cell. I'm not going to tell you about its gram stain yet because you'll be doing a gram stain on it. You'll determine for yourselves what its gram reaction is. It makes a spore. Often it makes a spore towards one end of that rod, and that's why it's laterosporous.